Hey everyone, in this 2-hour digital SAT math prep course, you're going to be able to access over 50 SAT math questions and solutions, all of which are vetted in straight from the College Board question bank. So you know those are the highest quality questions on the market. The percentage of questions in the video are also based on the content domain provided by College Board, and there's a mix of easy, medium, and hard questions. And if you're looking for digital SAT English prep, we have a full video that not only has practice problems, but covers all the concepts, grammar, everything you need for the English section of the SAT. Finally, if you want to score 1500 plus on your SAT, make sure you join our free newsletter using the links in the description, where we provide even more resources. That does it for all the mumbo jumbo intro. Good luck on your exam, and let's get into the video. The diagram below, line CD is a tangent and line EO is a secant. If arc AB is 60 degrees and the radius of the circle is 7 units, what is the length of secant EO? Pause the video, try the problem on your own. So for this problem, let's first look at what is given. Arc AB is 60 degrees. And by the way, there's multiple ways to solve this. It's just my way. If arc AB is 60 degrees, so this arc right here is 60 degrees, well, then we can just extrapolate that this angle AOB is also 60 degrees. Okay, cool. So next part, what is given? Well, it says the radius of the circle is 7 units. Well, guess what? We have the center O to any point. This line AO literally is from the center to the outside point of the circle. And therefore, that is 7 units. And we could say the same thing for BO here is 7 units, but that's not going to be really super useful besides determining one other thing, as we'll see later. So what can we do now? Well, first off, we know that this is 60 degrees, right? So I'm looking at this right now. I'm looking to see like there might be a triangle in this. If I take green and I take this green and I label it boom, 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 boom. Well, guess what? That is a triangle, okay? And whenever I see 60 degrees and triangle, I think, is there a special right triangle? And there is, because watch this. Let's switch back to my pen. We can see that from this line AO is really from the center to any point on the outside of the circle. And then guess what? Line CD is a tangent. And so that creates a 90-degree perpendicular angle. So this is 90 degrees. Oops. So that is 90 degrees. And well, guess what? There's 180 degrees in a triangle. And so this last angle right here, angle AEO, is going to be 30 degrees. So now we have a 30, 60, 90 special right triangle. And if we draw our triangle right here, this is on your reference sheet. So let's say this is 30 degrees, this is 60 degrees, and obviously the last side's 90 degrees. The shortest side is going to be opposite of our 30-degree angle, and so that is going to be denoted as X. And then our longer leg is going to be across from 60 degrees. That is going to be X times square root 3. And then our hypotenuse is just 2X. Now watch this. We want to find the length of our secant EO. Well, guess what? Our length of EO right here, well, that is just the hypotenuse, right? Because we know, we can see we have a value of 7 for the radius. That is across our 30-degree angle. And then what is across from our 60-degree angle is side EA in our triangle. And so we don't really care about that, but that would be, what is that? Because X, right? We know X would be equal to 7 based off this. That would just be 7 times square root 3 on this side. But what we really care about is the length of secant EO. That is just double 2x. And so if we take double of 7, that's just 14 as our final value of secant EO. And that is the answer to this problem. Density of gold is 19,320 kilograms per cubic meters. All right, let's write this as cubic meters. A given solid gold cube has a mass of 154.56 kilograms. What is the length in meters of one edge of this cube? Okay, so this is quite a tough problem. I feel like if you've taken AP chemistry, for those of you who've dealt with rate laws and those unit conversions and dimensional analysis, this one's probably a piece of cake. But let's solve this one. All right, so first, what do we know? Well, you kind of just have to know. I'm not sure if this is on the reference sheet. It probably is. That density is equivalent to mass over volume, okay? So let's rearrange this equation into volume equals, so let's multiply volume on both sides, and then divide both sides by our density. That's going to be equivalent to our mass over our density, okay? So this is helpful because we're dealing with units, and so we can't just straight up plug in numbers. Except, here's what's interesting. We know our volume, right? What exactly is our volume? Well, our volume is a cube, okay? And how do you find the volume of a cube? Side times side times side, or side cubed, right? And so we just need a placeholder variable. I'm just going to call it alpha. So that is alpha cubed, okay? Alpha in our case represents one edge of this cube. That's the length in meters. But alpha cubed means that alpha has a corresponding unit of meters, and so for cubing it, that must have the unit of meters cubed. Cool. So now we can set this equal to, so volume corresponds to this. Now, what do the other parts correspond to? Well, this top part is the mass. Well, it's given right here. 154.56 kilograms. Boom. Perfect. Now, what is under it? That is our density. And guess what? Our density is nicely given right here as well. That is 19,320 kilograms. Oops. Kilograms is very hard to write with a mouse. You'd think I'd be pretty good at it by now. All right. Per cubic meters. Cool. So, what can we do here? Actually works out super nicely for us because watch what happens. All right. If we just ignore the numbers for a second, we have meters cubed equals. Let's look at the right side specifically. We have kilograms over meters cubed. If you divide by a complex fraction, that's the same thing as multiplying by its reciprocal, right? So this is the same thing as multiplied by meters cubed over kilograms. I don't know why I wrote that as a subscript. So this is really, okay, this is kind of getting confusing. What we have up here is the same thing as kilograms multiplied by meters cubed over kilograms. And we can see that this, we would get the kilograms to cancel, and we're left with meters cubed. And so what does that mean? That means we have the same units on the left and right, and so we can just literally do the division right here to get our answer. So go ahead and take out a calculator and do the division on the right side, and then take the cube root of both sides and isolate and find our actual alpha value, the edge of this cube. If you do all that, you should get the final answer choice of 0.2, answer choice A. We have some inscribed shapes. It says, if the length of AB is x units, what is the area of the center circle? So, some important caveats before we start the question. Each of these semicircles are equivalent to each other in terms of area, and each of these semicircles are also exactly half the area of this center circle. Okay, with that in mind, how do we solve the question? Well, the first thing we want to do is write out the area equation for a circle, right? So that is going to be pi r squared. I see in our answer choices that there's nothing really we can manipulate besides define something with the variable x in it. How do we find the radius in terms of x? Well, we can see that we have features, right? We have features of our rectangle as x, one side of it x, and therefore we must find the radius in terms of x. So how do we do that? Well, we do have to get a little creative. So we see here, we can just split the entire shape down the middle. We have split the rectangle down the middle, and what does this do? Well, we can see that now it creates two equivalent semicircles, right? So these semicircles, the area that I've just highlighted, are equal to each other in terms of area. And that's interesting because we just split our original center circle down the middle. And so this is now 1/2, right? Each of these parts of our center circle is 1/2 of the original area. So if we were to add the other half to our new half, 1/2 plus 1/2 is just 1. So this area I've shaded in is the exact same area as that center circle. So what happens to x? Well, we just split the rectangle down the middle, and so x for this portion right here in red is really just 1/2 x. But we're trying to find everything in terms of our radius, right? Because we're trying to put it into the expression, and therefore we just have to look at half of this, right? Because we know that these two parts are equal to each other in terms of area, and therefore we can also just split this down the middle, and we know that this part, let me get green, this part right here will just be the radius. And therefore, how do we find the radius here? Well, we just take 1/2 of 1/2 x. 1/2 of 1/2 x is just 1/4 x, and now we have our radius. And so now we can do pi times our radius, which is 1/4 x squared, and then just some simple rearranging. So 1/4 squared is 1/16, and then x squared is just x squared. So this would be 1x squared multiplied by our pi on top. I'm actually just gonna write pi like this, save myself some characters. And so our area is gonna be pi times x squared over 16. And we can see that matches up with answer choice A, and therefore that is our answer. Product of 3 consecutive positive integers is equal to 56 more than the, ooh, wow. is equal to 56 more than the cube of the first integer. What is the largest of these integers? All right, so how we want to solve these problems is basically write them out as a expression, okay? So the product of three consecutive positive integers. So this can be represented as x as that first positive integer, and then a consecutive integer is x plus 1, right? We're just adding 1 to that. And we want to find the product of these three integers, and therefore we can write this as x times x plus 1 times x plus 2. All right, this is equal to, so we're going to write an equal sign, 56 more than the cube of the first integer. Remember, we denote the first integer as just x, and so the cube of the first integer is x cubed, and that is 56 more than this value. All right, so what is the largest of these integers? So we can just find the value of x, and we find the value of x, add 2 to it, that would be the largest of these integers. X times x plus 1 times x plus 2, this simplifies to x cubed plus 3x squared plus 2x. And this would be equivalent to x cubed plus 56. And so if we subtract x cubed and 56 from both sides, what we end up getting is 3x squared plus 2x, that's an ugly minus sign, plus 2x minus 56 would be equivalent to 0. So now that we have this expression, all we have to do is find the zeros of it. You can just plug this into Desmos. It will give you two solutions. One of them is a negative solution and is also not an integer, so that is not it. But the other one you'll find has an intersection at the point 4, 0, which indicates that one of the solutions, or the positive solution to this expression, would be x equals 4. And so we know x is equal to 4. And so now we can just take this. We know x would be 4 plus 2 is 2 after our first integer. That would be equal to 6. And so the largest of these three integers must be a value of 6. Our choice to pick is answer choice D. This one says there are two lawn mowing companies. Company A charges a flat fee of $80 for the first hour and then an hourly rate of $60 for each additional hour. Company B, on the other hand, has no flat fee but has an hourly rate of $75 per hour. After how many minutes will Company B's total cost exceed Company A's? So let's first write some equations. So we have Company A and then Company B. Company B's equation is pretty straightforward. We're just going to write y equals, where y equals the total cost of their services, and then x in our case will be the total number of hours. And so they don't have a flat fee and they just charge $75 per hour. So we're going to write this as 75x, and we're done with that part. Now we got to find the equation for A. We do the exact same thing. The total cost of their services, y, and then x in this case is the total number of hours. Now, let's be careful now. We can write 60x as their hourly rate because as x goes up by 1, that is their hourly rate. They're going to charge you $60. But now we have to do something more to this equation. We can't just leave it at 60x because remember they had a flat fee of $80. So for that first hour, they're going to be charging you just $80, right? So how can we adjust this equation so that it still satisfies the hourly rate of $60 for each additional hour, but still for the first hour, instead they charge $80? Well, all we have to do is simply add plus 20 at the end. You can see here that for each additional hour, we're going to be charging $60 because this is our slope. X is going to be 1. 60 times x would be 60 plus 20 equals 80, and that lines up with the flat fee of $80. So how do we actually solve the problem? How many minutes will Company B's total cost exceed Company A's, okay? So if we look at these two equations, we can see that the rate of change for B is higher than that of Company A. So B, let's say, is green. Their rate of change is like this. Oops, actually that's not accurate. They're going to be starting at 0, so they're going to be something like this. And then Company A, they're going to be starting up here somewhere for that flat rate, and then they're going to be going over like this, right? Their rate of change at 60x is going to be slightly lower than 75x. And so they're going to intersect at some point. So if we find this intersection point, we know that after that amount of time, right, after this amount of time, anything after that, well, Company B right here is going to exceed the total cost compared to Company A. So let's just find the intersection. This is a simple problem now. So let's set these two equal because they're both equal to y. So 60x plus 20 equals 75x. And now, to save myself some writing, let's do some mental gymnastics. So let's subtract 60x from both sides. We get 15x equals 20. And then we're going to divide both sides by 15. And therefore, x will be equivalent to 20 over 15. But we're not done yet because this, remember, is expressed in hours. And we want the answer in minutes. So we just have to multiply the number of hours, which is 20 over 15 hours, multiplied by 60 because there's 60 minutes in an hour. 60 times 20 over 15 will give us a final answer of 80 minutes. And therefore, that is our final answer for that problem. Quadratic function models the height and feet of an object above the ground in terms of time and seconds after the object is launched off an elevated surface. The model indicates the object has an initial height 10 feet off the ground and reaches its maximum height 1,034 feet above the ground 8 seconds after being launched. Based on the model, was the height in feet of the object above the ground 10 seconds after being launched. So a really easy way to solve this problem is just to use Desmos, right? I know it's crazy. Desmos is so easy to use. The only problem here is you have to do a little extra thinking, right? It's because they don't give you all the coordinate points that you need. We do know a couple things. So we know that the initial height is 10 feet above the ground. So when x is 0, we're going to have a value of 10. So that's our first coordinate point. And they also give us the maximum value of 8 seconds after being launched. It is 1,034 feet. Now the only problem with regression is that to use regression on Desmos, you need to have one extra coordinate point above your degree of the polynomial. So if I had a linear function, I could have 2 coordinate points and it would work. But since I have a quadratic, I need 3 coordinate points to make it work. Therefore, to find the last coordinate point, it's actually not that hard because you have to think about a quadratic function, right? If I have a quadratic function, I'm going to draw the other axis, and then the graph is going to look something like this, right? And what we know about quadratic function is that it's symmetrical, right? So if you were to think about this as 0, 10, right? And we think about the axis of symmetry as x equals 8, we know that everything is symmetric, right? So if this is x equals 0, and then this is x equals 8, then this value over here, when it returns back to the starting value, that has to be x equals 16, right? Because this is a change of 8, and this is also a change of 8. Side of the axis of symmetry is equal. Therefore, to find our other coordinate points, actually pretty simple because we know that this value, when it returns, has to have a y value of 10. And we already said that x is going to be 16. So we have 16, 10. We have our 3 coordinate points now, and now we just plug this into Desmos. As you can see here, just a table with the points, and we put in our regression, and it gives us our graph, right? It gives us the A, B, and C value. But the question is asking, what is the height and feet of the object above the ground 10 seconds after being launched? So since we already have the function that represents the problem, all we have to find is the value of the, what is this? The object, okay, the value of the object, or the height of the object 10 seconds after being launched when x equals 10, right? So we just put in x equals 10 here, found the intersection, we see that when x equals 10, the y value equals 970, therefore our answer is choice C. Alright, so this problem says if 4a over b equals 6.7 and a over bn equals 26.8, what is the value of n? So to help us find the value of n, it'd be very helpful for us to scale up everything, right? Because we already know what 4a over b is, that's equivalent to 6.7, so we can use that to help us compare the values to ultimately find n. So if we were to scale up this entire equation by 4, we'd have 4a over bn, and then we would have to multiply 26.8 by 4, which gives us a value of 107.2. Alright, so now it's just time to simplify, right? So what value of n would make this true? Well, because we don't actually know what the value of a or b is, we have to infer that based on our given information. We know 4a over b is 6.7, and we have 4a over b in our equation. So this simplifies out to just 6.7 over, and we have our n. So 6.7 over n is equivalent to 107.2. You can rearrange this to solve for n, and we would get a value of 6.7 over 107.2 equals n. And 6.7 over 107.2 also just simplifies to 1/16, and therefore our value of n is 1/16. Sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. Okay. The sample was created by combining two pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. What is the mass in grams of the silicon in the second piece? So to solve this problem, we need to set up a system, right? So what we know now is that the first piece and the second piece make up this certain sample of alloy. And so what we can determine is that the total mass, this is pretty much the only information we're given in terms of actual mass, is that the total mass of the alloy is 50 grams. So we can write 50 equals, and now we need to create some variables. Let's create it as x and y. So what we want to define here is essentially x is just the mass, total mass, important to note, total mass of the first piece, and then y is the total mass of the second piece. But what we want to solve in the problem is the mass in grams of the silicon, only the silicon in the second piece. So how exactly do we do it? Well, we have to read in between the lines. It says that 50% of that 50 grams is silicon. So 50 divided by 2 is 25 grams. So we only have 25 grams of silicon in that sample. Therefore, we can set 25 equal to, well, what are our other given equations? Well, not equations, but variables. We have the first piece, which is 30% silicon by mass, right? So you know x is the total mass, and therefore now we only have 30% of that for silicon. So we got 0.3x, and now we've got to do the same thing for the second piece, which is 80%. So 0.8 times the total mass. All right, so now that we've got these two systems of equations, we go over to Desmos and plug it in. So we can see, guys, we plugged it in here and we find the intersection. So this is our corresponding x and y values. It says what was the mass in grams of the silicon in the second piece. Remember, we labeled y as the second piece, the total mass of the second piece. And so the total mass of the second piece here is, you can see, 20. So 20 grams is the total mass. This is the total mass, not the silicon of the mass of the silicon, right? To find the mass of the silicon in the second piece, we need to multiply it by that 80% factor, right? Because only 80% of that 20 grams is actually silicon. So 20 multiplied by 0.8 gives us a grand total of 16 grams of silicon. Therefore, B is our answer. The table shows the results of a poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll of 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? So these 803 voters are selected at random. So whatever results we get from them, we can pretty much scale them up or expect the same proportion or ratio as if it was 6,424 people. Therefore, what we want to do here is find the actual difference that Angel Cruz wins by. So 483 subtracted by 320 gives us a value of 163 votes. So now that we have this number of 163, we can't just use this number because that's only of the 803 voters. We need to scale it up, right? And to find the scale factor, we can just apply the comparison between 803 and 6,424. So 6,424 over 803 should give us that scale factor, and that's going to be around 8. All right, so if our scale factor is 8, we know that the Angel Cruz wins by 163 votes with just 803 voters. We need to scale this 463 up by 8 times as well. And 163 times 8 gives us a value of 1,304, and therefore our answer here is going to be B. Dot plots represent the distributions of values in dataset A and B. which of the following statements must be true? So clause 1 says the median of dataset A is equal to the median of dataset B. And that's true because both distributions here you can see are symmetrical. If I were to draw a line down the middle, you have a equal number of points here and equal number of points on both sides, right? And so if you order the points from least to greatest and then you converge in the middle, you can see like on the ends, the 10 and the 16 cancel out, all the 11s and the 15s cancel out. You're always left in the middle with a value of 13. So let me just erase all that. So we know that the first clause here is true. So it can't be B and cannot be D. Let's see if the second clause is true. So it says the standard deviation of dataset A is equal to the standard deviation of dataset B. So here's the thing with symmetrical distributions, right? So when you got a symmetrical distribution, and you can calculate this if you don't remember this on the exam or something, is that when you have a symmetrical distribution, the mean and the median are the same, all right? They're equal. And so you can kind of see this in the points. You got a value of 10 and 16. Because it's symmetrical, they should theoretically not cancel out, right? But you're going to get a mean of 13, right? 16 plus 10, what is that? 26. 26 divided by 2 is 13. We have 4 points in the 11 section and 4 points in the 15 section. If we were to zoom in on one of those pairs, you got 11 and 15. That's also 26 divided by 2 is 13. You can see how here all the points in the pairs come back to the mean of 13. We know the median is 13 and the mean also is 13 for these symmetrical distributions. Now, going back to standard deviation. Standard deviation is the measure of spread in a data. So the farther away a point is from the center, you know that it is going to have a greater standard deviation. And so because even though they're both symmetrical, right, dataset A and dataset B looks different, right? It has like more points at 15, or has the same number of points at 15 and 11, but only has 1 point at 13. Whereas dataset A has a more condensed standard deviation here because of all those points at 13, and so their standard deviations cannot be the same, and therefore the correct answer here is going to be A1 only. Density of a certain type of wood is 353 kilograms per cubic meter. A sample of this type of wood is in the shape of a cube and has a mass of 345 kilograms. To the nearest hundredth of a meter, what is the length of one edge of this sample? All right, so as you know, density pretty much is the same regardless of how much you have of that material, right? So if we have a sample of this wood, the density of that wood is always going to be 353 kilograms per cubic meter. We know the equation for density is equivalent to mass over volume. And so if we are able to plug in values for density and mass, which we do have, we can solve for volume and ultimately find the length of one edge of the sample. So we know that density here is 353. I'm just going to ignore units. Mass here is 345 over V. If we solve for V here, we get V equals 0.977. So we know that the wood is in the shape of a cube, and so now we have the volume of that cube, right? And to find the length of one edge, we know that to find the volume of a cube, it's side length times width times height, right? And therefore, because we know that all sides are equal in a cube, we can just take the cube root of the volume to find one edge or side length. So the cube root of 0.977 is going to give us a value of around 0.99. Therefore, that lines up with our answer choice of B, and that is our answer. In the figure shown, lines R and S are parallel, and line M intersects both lines. So we got a parallel line cut by a transversal, so we want to be thinking about vertical angles, alternate interior angles, all that stuff. If Y is less than the value of 65, which of the following must be true? So let's just go right through it. So it says X has to be less than 150. So X is this angle right here. And because it says Y has to be less than 65, and which of the following must be true for all values of Y, we could just plug in a random value for Y. So let's just call Y 64 degrees, right? Because that satisfies that equation. And so now we know that this Y right here is 64 degrees. And so the angle opposite of that, that's going to be vertical angle. So this is also going to be 64 degrees. We can see here that this 64 degree angle and angle X, these are consecutive interior angles. And so what happens is that they are supplementary. So they have to add up to 180 degrees. So you get 180 minus 64, which gives us, oops, that was real messy. Okay, 64 equals 116 degrees. So interesting note here is that 116 is greater than 115. So that does not add up with A, and therefore A is wrong. If we were to lower this angle, which we would have to, I mean, if we had like 64.99, we would end up getting what, like 115.0001, right? But let's see if B is true. So it says B says X has to be greater than 115. Is that true? Well, we know that the biggest value of Y that we can have is 65, or not even 65 because it can't even be equivalent to it. It would have to be like 64.999. And therefore, if we had 180 minus 64.999, etc., right? That would yield what is that? 115.0000, etc., 1, right? That's messy, but you get the point. So basically, we can't ever go underneath 115 degrees for X if Y is less than 65. Therefore, B is our answer, but let's just check the other answers to be sure. So it says X plus Y has to be less than 180 degrees and X plus Y has to be greater than 180 degrees. Well, we just proved it here, right? We said that if Y, we could just name it 64 degrees. Vertical angles, this is 64 degrees. We find that X would have to be 116 degrees. 116 plus 64 is 180 degrees. And so neither C or D is correct because X plus Y will always be equivalent to 180 degrees. In the given system of equations, R is a constant. If the system has no solution, what is the value of R? So I already done some of the work here because writing with a mouse is very hard. So we just arrange the top equation into slope-intercept form. So we get Y equals 48x over 102 minus 24 over 102. And we compare that to the other equation, which is stated, Ry equals 16 minus 16x. So this is important because we want to know the actual slopes, right? So our actual slope here is 48x over 102. And this one over here is negative 16x. And this is important because when you talk about a system with no solution, that means the lines don't intersect. And in a system of linear equations, the only way that those two lines don't intersect is if those lines are parallel, right? And how do you get parallel lines? Well, you need the exact same slope, but different y-intercepts. So you can see here that, yeah, they have different y-intercepts, but they need the same slope, which they currently don't have, but we can give them the same slope by changing R to the correct value. Another thing to note here is that negative 16x can be rewritten as negative 48x over 3, right? That's the exact same thing as negative 16x. And now we can see the direct comparison between negative 48x over 3 and 48x over 102. So from 3 to 102, what value is that? Well, that value is 34, right? So if we get the value of 34, we can actually convert the denominator of 3 to the value of 102. Another thing here is that R, we know now, has to be 34, right? Because if we divide both sides by 34 in order to isolate for Y, dividing a fraction by 34 is the same thing as multiplying the denominator by that number. Another thing for R is that it will have to be negative. Why? Well, because this top slope is positive, right? But our current slope down here of negative 16x, that is negative, and that translated over here. We have negative 48x over 3 instead of a positive slope. And so if R is a negative number, that means ultimately when we multiply it into that denominator of 3, we're going to get a negative value in the denominator as well. A negative over a negative is a positive, and therefore we will get a positive slope there, which should work out. So let's just go right through. If we set R equal to negative 34, let's see what happens. So we get negative 48x divided by 3. So we're going to divide everything by negative 34. And that's the same thing as multiplying the denominator here by negative 34. So we'll get negative 48x over 3 times negative 34 is negative 102. So negative 102 or negative 48x over negative 102, like we said before, is the same thing as just 48x over 102. So we can see now that these slopes do line up, right? 48x over 102, 48x over 102. It's kind of messy, but you get the idea. The other thing we have to make sure here is that the y-intercepts are different, and they are vastly different, right? We got 1/6, and if we have a value of negative 34, that's the same thing as multiplying 6 by negative 34. That will give us a very small number, right? A much smaller number compared to 24 over 102. Now, that means that the value of r has to be negative 34. But that was such a long, complicated process, so there is an easier way. And that easier way is, of course, Desmos. All right, all you gotta do is plug the top equation in, plug the second equation in, have that r, set a slider for r, and just drag that point, right? Just drag this until those two lines are parallel, right? Until those two lines don't intersect, that is your value of r. That is the value of r that satisfies the equation when there is no solution. Which expression is equivalent to 42a over k plus 42ak, where k is a value greater than 0, and we get all these answer choices. All right, so what we're going to do here is pretty much just try and simplify this into its simplest form, essentially. So we get 42a. Oh wait, actually, let me backtrack. So you get 42a over k, right? And we get 42ak over 1, let's say. And now what we can do is actually find the common denominator here. And the common denominator is very simple for this problem. It's just k, right? So this right here just stays as 42a over k because it already had k in it. And we want to add, and we're going to multiply this 1 by k, right? So we're multiplying both the numerator and denominator by k. So we get 42ak times k. And the reason we're doing that is to find a common denominator, and the k's here, k over k is 1, so it really is the same thing, right? It's the equivalent expression or form, but we just want a common denominator here because now that we have the same denominator, we can combine the numerators. We get 42a plus whatever over k. And so now we can see that k is going to be applied to this value. Now, be careful here, it's not distributive property. This 42ak, look at it as one term, right? One singular term. So this k can't be applied to the 42, can't be applied to the a, but can be applied to the k value. So now we get 42a k, and the k times the k is just k squared. All right, so now we need to factor out the greatest common value from the top. So that is going to be 42a, and 42a times 1 will give us this first value of 42a, and then plus k squared, which is going to give us 42a times k squared will give us the second value all over k. All right. So after doing that factoring, you realize that the answer choice that we got matches up distinctly with answer choice D. It's just flopped, right? This and this is flopped, but it is what it is because it's the equivalent form. Therefore, D is our answer. A salesperson's total earnings consists of a base salary X dollars per year plus a commissions earning of 11% of the total sales the salesperson makes during the year. All right, so let's just write this out. So the salesperson is going to make a base salary of X, and he's going to get on top of that 11%. So we'll just express this as 0.11 of the total sales. So the total sales, let's just call it S. Okay. So it says this year the salesperson has a goal for the total earnings. So this value right here, the total earnings, to be at least 3 times and at most 4 times the base salary. The base salary, remember, is the value X. Which of the following inequalities represents all possible values of total sales S in dollars the salesperson can make this year in order to meet that goal? And so we just have to write our inequality out. So I'm actually just going to erase this and write our inequality. So we know that has to be at least 3 times the base salary. So 3x is less than or equal to our total earnings, and at most 4 times the base salary. So that's going to be less than or equal to 4x. All right, so now that we're looking at our answer choices, none of them actually line up, right? C is similar, right, with 3x and 4x, but it just has s in the middle, whereas we have x plus 0.11s. Therefore, in order to actually get an answer that matches up with one of the answer choices, we need to simplify this inequality. So here, very simple, we can just subtract x on all sides, and we end up getting 2x less than or equal to 0.11s is less than or equal to 3x. And now again, we want to isolate for s because you see in all these answer choices, s is by itself in the middle as the total sales. Therefore, we can just divide all sides by 0.11. So we get 2x over 0.11 is less than or equal to s less than or equal to 3x over 0.11. And we can see that this answer choice right here lines up directly with answer choice B, and therefore that is our answer. This one says, in the given equation, B is a positive integer. The equation has no real solution. What is the greatest possible value of B? So they give us a quadratic equation, negative x squared plus bx minus 676 equals 0. So in order for us to solve this problem, we need to calculate what is called the discriminant. So the discriminant is what you're going to find in that quadratic formula. So that is square root of b squared minus 4ac. All right, so if you didn't know, the discriminant determines the number of solutions a function has, or a quadratic function has. So if this value is positive, that means it has 2 solutions. If it is negative, then that means it has 0 solutions. And if it's equivalent to 0, that means it has 1 real solution. So in order for us to calculate this, we just need to know what the this part right here, the negative 4 times a times c, is equivalent to, and then just find a b value that is less than that, but the greatest possible value. I'll show you how to do that. So let's first calculate negative 4 times a, we know our a value is negative 1, times c, our c value is negative 676. And this will give us a value of negative 2,704. All right. So as we talked about before, we need to know that the value of b squared has to be less than 2,704, but it has to be the greatest possible value. So what we can do is just set b squared equivalent to 2,704. Not negative 2,704 because this has to be a positive value in order to be subtracted, right? And so now we're just going to solve for b. So if we take the square root of both sides, we're going to get b is equivalent to the square root of 2,704, which is oddly equivalent to an odd number, whole number, which is equivalent to 52. Now 52 is not our final answer, because if b is equivalent to 52, our discriminant would be equal to 0, and we would have 1 solution. But this equation has no real solution. And so we know that b is a positive integer. So in order for b to be a positive integer, it is just the number that is below 52. So the next closest value under 52 would be 51. And so the greatest possible value for b is 51, because if we can test this, 51 squared is 2,601. And that is indeed smaller than 2,704. And so if you did the math there, you would get a negative value. And so the discriminant would have a negative value, meaning you would get no solution. And that would ultimately solve the problem. The expression 3 times 2x squared plus px plus 8 minus 16x times p plus 4. P is a constant. This expression is equivalent to the expression 6x squared minus 455x plus 24. What is the value of p? So here we have 2 missing variables in this one equation. So that is going to make it a little bit tricky to solve. But the thing to notice here is that p is only in the values of x. So what I mean by that is you can see 3 times px, right? That's going to give you 3px. And then over here, you have negative 16x times p. That's negative 16px, right? So that is all under the same x term. If we look over here, that means it's only going to affect this term right here, negative 155x, because p can be anything and it won't affect the 6x squared or the plus 24 constant. All right, so let's set up our equivalent equation, because it says this expression is equivalent to the expression. Therefore, we can set up that equation, isolate for p, and we'll be good to go. So the 3 times px is just 3p. And I'm going to negate the x's for each of them because x is in each of these equations and it's just a substitute variable. So we can just negate that. Over here we have negative 16x times p. So just negative 16p. And I almost forgot the plus 4. So p plus 4. And that is all equivalent to, we're negating the x, so that's just negative 155. All right, let's just do some distributive property. So negative 16 times p, negative 16p. Oopsies, okay. All right, negative 16 times positive 4 is just negative 64. And then we have 3p on this side. And this is equivalent to negative 155. And let's just do some simple algebra, right? We add 64 on both sides. And that will give us 91 on this side. And so now we're left with 3p minus 16p on the left side. And that will give us negative 13p. All right, and we can divide by negative 13. Boom, boom. Oh, I actually made a mistake here. It's negative 91. That makes sense because a negative over a negative. So negative 91 divided by negative 13 gives us p is equivalent to 7. All right. So our answer choice is B. The line with the equation 4/5 x plus 1/3 y equals 1 is graphed in the xy plane. What is the x-coordinate of the x-intercept of the line? So we're looking for the x-coordinate of the x-intercept of the line. All right, so the x-intercept. The x-intercept is where, let's say you graphed. I'm just going to write a random equation. So let's just say we have like a quadratic formula, right? So these, where it hits the x-axis, would be the x-intercepts, right? The zeros. And so at these points, if you were to write out the coordinates, you would have 0 as your y value, right? Because whatever x value you have, it outputs a y value of 0. And so in our case, we know that the y value in this equation, it has to be 0 if we're representing it to find the x-coordinate of the x-intercept. So then we have 4/5 x plus 1/3 times 0 is 0. So plus 0 equals 1. And now we can just solve for x, because if we solve for x, because y was 0, then that means we're solving for the input that gets us 0 as y. And this is a function. So what is x? Well, what do we multiply 4/5 by to get 1? Well, we can multiply 4/5 by 5/4, right? Because this gets us 20 on top and 20 on the bottom, and that is equivalent to 1. And therefore, the x-coordinate of the x-intercept would just be 5/5. So that is our answer. Figure AC equals CD, okay? And the measure of angle EBC is 45 degrees. So let's label that. Boom. Okay, and the measure of angle ACD is 104 degrees. What is the value of x in degrees? So the value of angle AEB, that's what we're trying to find. So the angle of AEB. Okay, so how I like to approach, just geometry problems in general when you're trying to find an angle is just, don't try and take it in all at once. Just take it step by step, break it down, see what angles you can find, see what theorems you can implement, and eventually, you never know, you might find the answer from that. So first off, they tell us that AC equals CD. So this triangle right here, triangle ADC, this is a isosceles triangle, right? Because these two side lengths are equal, then we know that these angles here, angle D and angle A, are going to be equal to each other. Because there's only 180 degrees in a triangle, and we know angles ACD is 104. I should add evens. Boom, boom. So that gives us 76 degrees between those two angles. And so we can divide that in half, and we get 38 degrees. So we know each of these angles, so angle A is 38 degrees, and angle B is also 38 degrees. Okay, so that's one step of the puzzle. So how exactly can we find angle this X, right? So one way I'm looking at it right now is it's on this line right here, and we can use what's called the supplementary angles, right? Because two angles on a straight line will have to equal 180 degrees. So if you find this angle right here, angle DEB, whatever that is, if we find that value, then we can just subtract 180 minus that value, and then we get whatever X is going to be. So is there a way to find angle DEB? Well, it's actually pretty interesting because they gave us the measure of EBC, this angle up here, and we just figured out the angle of BDE. And so these two angles make up a portion of this triangle, right? So it's this triangle right here. Boom, boom, boom. Oops. This triangle. All right. So we know there is, let me just switch back. There is 180 degrees in a triangle. So if we found two of the angles, 45 degrees and also 38 degrees, then we can find the last value. And this last value, let's do some quick maths. I think that is 97 degrees. Okay, so angle E is 97 degrees. All right. All right, so as we said before, now we can use supplementary angles. So we know these two angles, this angle we just found here, 97 degrees, and angle X, together they will have to equal, so 97 degrees plus X, whatever that is in degrees, has to equal 180 degrees. And so we can do some simple maths. 83 is our final answer. So the value of X would be 83 degrees. And I think they want you to represent it as just the value without the degrees, because they already state the degrees here. And so if you're really finding X, the actual answer is just 83. So this is a very common percent problem that you might, get on your exam. So it says the result of increasing the quantity X by 400% is 60. What is the value of X? All right. So first off, let's just write a mathematical equation to represent this scenario. So we have X, that's our starting value. We're increasing the quantity of X by 400%, right? So we're adding 400% of X to X. So we can just represent this by plus 4X. And we know our final value will be 60. And so in reality, this will just be 5X equals, it's not letting me write today, 5X equals 60. Therefore, solve for X, that's going to be 12, right? So another way you could think about this is that if you increase the quantity by 100%, you're doubling it. So if you increase it by 200%, you're tripling it. And therefore, in reality, by increasing the quantity by 400%, you're really just multiplying the original value by 5. And so 60 divided by 5 is 12. And yeah, that's an easy way to think about it. Adam's school is a 20-minute walk or a 5-minute bus ride away from his house. The bus runs once every 30 minutes, and the number of minutes W that Adam waits for the bus varies between 0 and 30. Which of the following inequalities gives the values of W for which it would be faster for Adam to walk to school? Right, so the first thing you notice here is that for all of our inequalities, everything on the right side is a constant 20, right? So that represents that 20-minute walk that Adam has the option to take. Everything on the left side, therefore, represents that bus ride. So it's the 5 minutes of the bus ride from his house to the school, including that waiting time from between 0 to 30 minutes. So if we want the inequality that shows that it's faster for Adam to walk to school, that means that 20 minutes is going to have to be less than whatever's on the left side, because then that shows that it takes less time, right? So first off, we can eliminate two answer choices because these don't show that relationship. So the first one is A, and then the second one is C, right? These show that 20 is greater than the left side, which we don't want. And now we're down to B or D. Well, the thing with B is it shows W minus 5. In reality, this doesn't really make any sense because that 5-minute bus ride is included in the waiting time, right? So the waiting time here is W, the amount of time that Adam has to wait for the bus. And so we want to add on that 5 minutes because it takes 5 minutes to actually get on that bus from his house and actually arrive at school. And therefore, it can't be minus 5 because we're not taking away time, that's just adding time to him. And therefore, our answer is going to be choice D. Shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like a rectangular prism, which I've drawn one out here, it's a pretty good drawing actually, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width x in inches of the box. All right, so first off, let's label our diagram, right? So we know the height they give us is 60 inches, so let's just write 60 out here. Oopsies. There, 60. And then they also give us the width, which is x. Well, we don't really have a value for x, so we'll just label x out here. We know the length is 2.5 times the width, so we just write this as 2.5x, right? And now what we need to do is set up our inequality. So let's use green and write out 130 because it cannot exceed 130, right? And therefore, I'm going to write up the sign like this, but it can be equal to 130. It just can't exceed 130. All right, so now we need to find what the restriction actually is for the 130 inches, right? Well, it says right here, it's the sum of the perimeter of the base of the box and the height of the box. And so the height of the box, first off, we have a value of 60. So we have 60. And it's the sum, so we're going to add this to whatever we have with the perimeter of the base of the box. So the perimeter of the base of the box is just that base, that one side, right? So that one side, we're going to have that length and that width. However, there's that other side. I'm trying to make the drawing. So this is a three-dimensional object. So you have two widths in reality, right? So you have a width on this side right here, and you have a width on the other side. And the same thing with the length, right? So you have 2.5x on one side and 2.5x on the other side. And therefore, when we write our inequality to find the perimeter of that one, side, we can just double the addition of both the length and the width. And so we can write this as 2 times 2.5x plus x. All right, so now what we want to do is just expand this out. So 2 times 2.5x will just give us 5x. And then 2 times x is going to be 2x. And so we get 7x over here. So in our equation, we're going to have 60 plus 7x. And that is going to be less than or equal to 130. And now we can just solve for x, right? Because x is going to be that width that we're trying to solve for. And so we can just subtract 60 on both sides, and we get 70 is greater or less than 7x. Divide both sides by 7, and we get x is less than or equal to 10. So we get this inequality over here, and we want to match it up to the answer choices. So let's look at our answer choices. So for A, we have x is greater than 0, but less than or equal to 10. Well, that actually lines up exactly with our equation, right? For all these inequalities, the minimum or x has to be greater than 0, which makes sense because you can't have a width of 0, right, for a box like a rectangular prism. And therefore, since this part of the inequality matches up with what we have down here, it's the same thing but flipped, our answer choice is going to be A. Ben is working this summer as a part of a crew on a farm. he earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves only 90% of his earnings from each week, which is the least number of hours he must work the rest of the week to save at least $270. So first off, let's just set up our inequality, right? So he needs to save at least $270, right? 270. And so he can save more than 270, but he needs to save at least 270. So greater than or equal to, and then his savings, it says right here, he saves only 90% of whatever he earns, right? So whatever we have with his $8 per hour or $10 per hour for X amount of hours, right? All that is going to be cut down by 90%. So we can write a 0.9 on the outside and then a parentheses for all of our values on the inside, right? So the first thing we want to account for is his initial 10 hours that he worked. So he worked that initial 10 hours at a rate of $8 per hour, right? And therefore, since he worked 10 hours at $8 per hour, he made $80. So we just write a flat $80 right there. But then his performance increased, right? And therefore his salary also increased. It says his crew raised his salary to $10 per hour. We don't know how many hours he's going to work at $10 an hour, but we know that he must work a certain amount of hours to make at least $270. Sorry, to save at least $270. Therefore, we can write this as plus 10, because that's the flat rate. And then we can just write X as the number of hours he works. And X, in our case, in this inequality, will represent the least number of hours he must work to save at least $270. All right, so now we just want to simplify this inequality, right? So 0.9 times 80 is going to give us a value of 72. 0.9 times 10x is going to be plus 9x. Set this equal to greater than or equal to 270. Okay. And so we want to subtract 72 from both sides because we're isolating for x. And so we get 198 is less than or equal to 9x. Divide both sides by 9 and we get a value of 22 is less than or equal to x. All right, so what does this represent? Well, this means that in order to save at least $270, they will have to work, or who's there? Ken will have to work at least 22 hours, right? But this also means that, you know, if he works greater than 22 hours, he'll save more than $270. But we just want to find the number of hours that it'll take him to save at least 270 hours, working the least number of hours, right? And the least number of hours in our case is right here, 22 hours, because that's the minimum that he has to work. And therefore, our answer choice is going to be C. Intersecting lines R, S, and T are shown below. What is the value of X? Well, they give us two angle measures, right? We have this 106 degrees out here and 23 degrees out here. So the first thing you want to take note of is supplementary angles, right? So because this 106 degree angle is on this line S, this missing angle here, which actually represents this triangle, that is going to mean that 180 degrees minus 106 degrees is going to be equal to this missing angle. And so we can pretty easily just do 180 minus 106, and that will give us a value of 74. So we know this angle right here is going to be 74 degrees. And now we have two angle measures of a triangle, and so we can find the missing angle measure, right? So this angle right here at the bottom. And so we just do 180 minus 23 minus 74, and we get a value of 83. So because this side right here, or this angle, is 83 degrees, that means we can also use supplementary angles again to find the value of X. Now why? Because we have two angles lying on the line R, right? So any two angles on a line will be equivalent to 180 degrees. And so here we're going to just do 180 minus 83 and get our value of X, which is going to be 97 degrees. And yeah, that's how you see O is the center of the circle above. And the measure of angle OAB is 30 degrees. All right, so that's going to be 30 degrees right there. Boom. If the length of line segment OC is 18, so this is 18, what is the length of arc AB? So I think this is the minor arc of AB right here. Well, the first thing to note here is that OC represents the radius, right? Or the radius, the radius. So because OC is the radius, right? Because it goes from one point on the circle to the center, we know that the radius has a value of 18. Now the same thing happens from B to O, and as well as A to O. And therefore we know that the side length of AO is going to be 18. So let me write. Is 18, and the side length of BO is also 18. Now here's what's interesting, right? Because these two side lengths are equal, right? We know they're opposite angles. The angles opposite to them are also going to be the same, right? And so if this right here, a 30-degree angle is opposite of 18, we know that this angle right here is also going to be 30 degrees. And it's kind of funny because now we have an isosceles triangle, right? So it works out in the end. So this angle right here we can conclude is 120 degrees. Boom. All right, so now how do we actually solve for the length of AB, right? Well, here's the thing. We know that AOB, that angle, the 120 degrees right here, that is the inscribed angle of the arc of AB. So technically speaking, the length of the arc is 120 degrees. However, we want to express it in, first off, radians, and also it'll be based on the circumference of the circle, right? So first off, let's just find the circumference of the circle. So the circumference of a circle is equivalent to 2 pi times radians. And therefore our radians, the radius, not the radians. So the radius is equivalent to 18, right? So we can just do 2 times 18 is 36 pi. And so that is our circumference, all right? And so in order to calculate the length of the arc, what we can just do is first just find the ratio to scale it up. So we have 120 degrees over 360. So that in reality in itself is just 1/3, right? So what we want to do is just take 1/3 of that circumference. And so 1/3 of that circumference, which we know the circumference is 36 pi. So 36 pi, let's just divide this by 3. Because we know that this angle represents 1/3 of it. And so we can just do 36 over 3, which is 12, and keep the pi, so we don't have to simplify it completely. And so our final answer here is going to be an answer of 12 pi, and let's see, it does match up with answer choice B, and therefore that is our answer. So it says a rectangle is inscribed in a circle such that the vertex of the rectangle lies on the circumference of the circle. All right, first let's just draw this out, right? So the first thing you have to do with these geometry problems is interpret them. And, there's all this weird wording there, but as long as you just take it step by step, word by word, you'll be fine. So the rectangle is inscribed inside of a circle. So I'm going to draw a circle and then draw a rectangle. So the rectangle is drawn such that the vertex, or each corner of the rectangle, lies on the circumference of the circle. So what it's going to look like is one corner goes there, boom. And then the corners of that rectangle are going to be on the circumference or the outside of that circle. So there's our drawing. It says the diagonal of the rectangle is twice the length of the shortest side of the rectangle. All right, let's draw that in. So the diagonal, which is going to look like this, just going across from one corner to the other, is going to be twice the length of the shortest side of the rectangle. So this right here is our shortest side, and so let's just label that X. Let's call that X. And it's twice the length, so we can call this 2X. Therefore, that is twice the length. The area of the rectangle is 1089 times square root 3 square units. What is the length in units of the diameter of the circle? All right, so the diameter of the circle, right, is just its radius times 2, because that's just from one end of the circumference to the other end of the circle. And you can see that the diagonal actually, satisfies that condition. And therefore, the diagonal of this rectangle is that diameter of the circle. But how do we actually find our side lengths? Well, you have to use this thing on the side. That's the reference table that the digital SAT provides, right? This is provided to you. You have to focus up top on the special right triangles, all right? So if you're not thinking of special right triangles, you might be in a bottomless pit trying to solve this problem, because special right triangles is the easiest and fastest way to do this. So you can see here, for one of our special right triangles, the 30, 60, 90, we have side lengths 2x, x, and x times square root 3. That matches up with this triangle over here, right? We have side lengths x for one of the legs, the hypotenuse is 2x, and therefore we can infer that the other side is going to be x times square root 3. So x times square root 3 is going to be our final side for that part of the rectangle. And we know length times width equals the area of a rectangle, and we have the width right here and the length right here. And so we just have to multiply those together. So x times x square root 3 is going to give us the area that they provided. So it's 1089 multiplied by square root 3 square units. And all we have to do now is solve for x. So you can plug this right into Desmos and it'll give you an answer of x equals 33. And so now that we know what x is, all we have to do is plug it in here, right? So x is 33, so we know one of the side lengths is 33, but that diameter is that diagonal of the rectangle. And the diagonal of the rectangle is 2x. And so 2 times 33 gives us 66 as our final answer. Function f is defined by the standard form of a quadratic. A, b, c are constants. When it's graph, it passes through these points. So these 2 points, 7, 0, and negative 3, 0, these are the x-intercepts. It says if a is an integer greater than 1, which of the following could be? So could means that there are multiple possible values, but just based on our selections here with our choices, which one could be a value of a plus b? So first off, let's just write what we know. So we know f of x is our function, and a is an integer greater than 1, except we don't know what it is, right? So let's just write a to represent it. However, what we do know are the roots, and that is 7, 0, and negative 3, 0. So when you have these coordinate points as solutions, you can rewrite them in their factored form. So 7, 0 can be rewritten as x minus 7, because when you set this equal to 0, you solve and get positive 7. And negative 3, 0 can be rewritten as x plus 3. Right, that's interesting. But now to actually expand this out and actually get a value for b, what you might realize here is that we need to actually have a value for a, right? So it says a is an integer greater than 1. Well, what's an integer that's right above 1? Well, 2. So let's just have a value of 2 for a. So then we have 2 times x minus 7, and then x plus 3. So now we can just expand this out. So let's just do this part first. So we have x squared, and then we'll get negative 4x, and then minus 21. So then we have to apply the 2 right here to the outside. So then we have to multiply this entire thing by 2. So then we get 2x squared minus 8x minus 42. Right, there we go. So it says, which of the following could be a value of a plus b? Well, which ones are a value, which is right here, a value, and our b value, right here. So our a value is positive 2, and our b value is negative 8. And if we add those together, positive 2 plus negative 8 is just 2 minus 8. That's going to give us the answer choice of A. A circle in the xy plane has its center at coordinates negative 4, negative 6. Line K is tangent to the circle at the points negative 7, negative 7. What is the slope of line K? So this is an interesting problem because when you talk about like geometry on the SAT, you don't really get too much into the obscure concepts. So we have tangent lines on a circle. This one thankfully is quite simple and straightforward, so I'll show you how it's done. So if we draw like the coordinate plane here, and we know that the circle has its center at these coordinates, negative 4, negative 6. So it's like going to be somewhere, I don't know, like right here. And we don't actually know the radius of the circle. We probably could calculate it using these points and finding the distance and stuff, but that's not really relevant for our problem, and you'll see why. So line K is tangent to the circle at the point negative 7, negative 7. And so negative 7 is out here somewhere. And so, I mean, the radius is going to be like somewhere like this. So we have that. That's a really lopsided, ugly looking circle and probably not drawn to scale or accurately. But this is just a visual representation. And so line K, I'm going to draw in black here, is tangent to the circle at this one point right here, which means the tangent line is going to go through like this, because tangent lines are going to hit at only one point on that circle. So it'll go infinitely on both sides. And so we want to know the slope of this line. So the only way to determine the slope of this line is to use the information we already know. So we know 2 coordinate points, right? And these 2 coordinate points, only one of them are actually on line K. And so what we need to do here is actually find the slope of the perpendicular line to line K. So if we draw another line through the green line, that's a bad diagram. So we draw it through like this. Just pretend that's a straight line. You can see that the green line is going to make a perpendicular angle with line K. And so those are perpendicular lines. And perpendicular lines have opposite reciprocal slopes. And therefore, what we need to do is actually just find the slope of line K. Find the slope of the green line here, and then we can find the slope of line K. So the slope of the green line, let's draw over here, is going to be based on these 2 coordinate points. So the equation is going to be y2 minus y1 over x2 minus x1. And so here, let's just look for the change in y. So the change in y, we're going to be going from -7, -7 to -4, -6. And so the change in y, which is -7 to -6, that's a change of +1. So +1 on top. Now the change in x, so we're going from -7 to -4. That's an increase of +3. And so, right, +3. And so we know the slope of this line is 1/3, and which makes sense because if you look at the diagram, it is positive. It's going to be positively linear, and therefore a positive slope as 1/3 makes sense. So then what is the slope of line K? Well, we just need to take the opposite reciprocal, and the opposite reciprocal here is going to be -3. And therefore our answer choice is going to be A. Function h is defined by h of k equals ax plus b, where a and b are positive constants. All right, so let's just keep that in mind. The graph of y equals h of x in the xy plane passes through 0, 10 and -2, 3, 25 over 36. What is the value of a plus b? All right, so when they give you these 2 coordinate points and a general equation like we have here, ax plus b, let's just start plugging in the numbers and see what we can make of it, right? So h of x is just our output or our y value, and we can see here in the first one, our y value or output will be 10. So we have 10 equals, we don't know what a and b are, but we can figure it out from these values. So here it says that with the input of 0, so x equals 0, we're going to get an output of 10. Well, let's see. So a to the power of 0 is going to give us 1. So here we have 1. So 10 equals 1. So this is plus b. And so what added to 1 gives us 10? Well, that is going to give us a value of 9. So we still do not know what the value of a is, but we know whatever a is to the power of 0 is going to be 1. But we have now just found out the value of b, right? And it makes sense because b is a positive constant. Now what we want to do is tackle the second part. So the second part here is -2, 325 over 36. So let's see what we can do here now that we know what the b value is. So we know the output is going to be 325 over 36. So 325 over 36. And we want to set this equivalent to just our general form ax. So a, we don't know what that is. X here, in our case, right here it says it's -2. So -2. And we already found the b value from our previous journey up there. So that's going to be plus 9. And so now what we want to do is just solve for a, right? So we can subtract 9 on both sides. And this is actually interesting because 325 over 36, 9 times 36 is going to give us 324. And so when we subtract 9 on both sides, that's in reality is just subtracting 324 divided by 36. And this will be set equal to a to the power of -2. And so if we want to solve for a here, let's simplify the left side. That is going to be 1 over 36 equals a to the power of -2. And you can plug this into Desmos and solve it, but here there's just exponent properties. So a to the -2, that is the same thing here as just 1 over a to the power of 2. And so because we have 1 over 36 equals 1 over a to the power of 2, what we can do here is just disregard everything on top. because we can take the reciprocal of both sides. So this in reality really is just 36 equivalent to a squared. So now what we can do is just solve for a by taking the square root of both sides. And on the SAT, when you take the square root, when you manually take the square root of something, you are taking the principal square root, and therefore you only want the positive solution. And so instead of -6 and 6, it's just going to be +6 as our final answer. So +6 here is our answer for A, but the question is asking for the product of A and B. So we know here that B is a value of +9, and A is a value of +6. So 9 times 6 is going to give us a value of 54, and therefore C is going to be our final answer. All right, so the next problem says a circle in the xy plane has a center at those coordinates of -5, 2, and has a radius of 9. The equation of the circle is x squared plus y squared plus ax plus by plus c equals 0, where a, b, and c are constants. What is the value of c? All right, so the thing here is we've drawn out what we have, the standard form for a circle, right? And so what we have are these centered coordinates, and we know the centered coordinates correspond with h and k respectively in this equation. And we also know the radius, so we can just plug these numbers in. And so here we'll have x, and because we have a -5 and the standard form here is a negative, in reality h here, h is -5, right? So if you take a negative of a negative, that's in reality just positive. So x plus 5 here is going to be squared plus y minus k. K here is just +2 squared equals the radius squared. The radius we know is 9, so 9 squared is 81. And so now what you'll realize is if we just expand this out, right? We have two parts here that we can expand out. If we expand this out, it'll become eerily similar to the form we have here, because we're going to break it up into the x squared, the ax, the y squared, and the y parts. And so here we have x plus 5 squared, which is the same thing as just x squared plus 10x plus 25. I'm going to switch colors for the y minus 2 part. That is going to be plus y squared minus 4x plus +4 equals 81. And so what we're interested in seeing here is the c value, right? The c value is the constant, and it doesn't have the x or x squared in front of it. And so because of that, we can actually determine what it is, because on this side you can see it's 0, but on our side here is value of 81. So what we need to do is subtract 81 on both sides. Boom, boom, boom. And then once we subtract 81 on both sides, we just want to combine like terms, right? We have a +25 here, a +4 here, and then a -81 here. So here we just have 29 minus 81. And 29 minus 81 will give us a value of -54. And therefore we can determine that the value of c here is just going to be -52. In the figure shown, points Q, R, S, and T lie on the line segment PV, and line segment RU intersects line segment SX at point W. The measure of angle, so I want to mark this down, of angle SQX is 48 degrees. So let's write 48 there. Okay. And the measure of angle SXQ is 86 degrees. So let's write 86 there. Okay. The measure of SWU is 85 degrees. So let's write 85 there. Boom. And the measure of VTU is 162 degrees. And the problem says, what is the measure in degrees of angle TUR? So this is the angle we're trying to find. So let's see. So they gave us a bunch of angle measures, and now we just have to implement theorems that we know in order to find those missing angle measures. So the first thing I want to point out here is that we have two angles on a straight line, right? So we have angle VTU, which we know is 162 degrees, and this angle UTS. So this angle right here would just be 180 minus 162. All right. So 180 minus 162 is just 18 degrees. So we know that this angle right here has to be 18 degrees. And so why did I find that angle? Well, because in order to find angle TUR, I want to highlight this. What we can do is actually just find two of the angles in this triangle, because we know there's 180 degrees in a triangle. So if we find this angle, the one we just found, the 18 degrees, oops, switch. If we find this angle, and we also find, let's say, this angle in the corner, then we can just do some math to find the missing angle. So is there a way to find angle TRU? Well, it is a part of another triangle, right, over here. And so now we really have to think, what can we do? So first off, we have this 85-degree angle here, and we have a very straightforward vertical angles theorem here. So this angle right here, which is across from the 85 degrees, that is also 85 degrees. And now another thing I want to note out is that this quadrilateral QRWX has four sides, right? And it's a closed shape. So because of that, I just want to highlight this. This will have 360 degrees, right? And so what we've just done is we found three of the angle measures. So we found 85 degrees, and then we found, well, we didn't really find this, they gave it to us, 86 degrees, and then they also gave us that 48 degrees. And so now if you want to find this angle in the corner right here, angle QRW, we just have to subtract 360 minus all those other angles. And so that gets us 141 degrees. Now, what does that really help us find? Well, first off, it's getting a little messy over here, so I'm just going to erase a bunch of this. So now we've found that this angle right here is 141 degrees, right? And again, that we have two angles on a straight line. So that has to equivalent to 180 degrees. So what is this angle right here? Well, that's just 180 minus 141. And 180 minus 141 is just 39 degrees. And so, if we find this angle TRU, we now have two missing angles. We found the two missing angles of the triangle that we initially wanted to find, which was this one right here, right? So we know that because a triangle has 180 degrees, then we just found the 39 degrees in this corner right here, 39. And we already found this one from the other calculation we did of 18 degrees for this angle. So we can just add these together, subtract it from 180, and we get 123 degrees. Yeah, that is our final answer for the measure of angle TUR. It says, in right triangle RST, the sum of the measures of angle R and angle S is 90 degrees. So angle T is the 90 degree angle. The value of sine R is square root 15 over 4. What is the value of cosine S? So let's draw a right triangle here. So you know R, just put up here, angle S, and T is the 90 degree angle. All right. So the value of sine R, so sine, we know, if you know SOHCAHTOA, is opposite over hypotenuse. Oops. Opposite over hypotenuse. So if we look at this angle measure, the opposite side length of this angle is over here. So this value will have the square root of 15. And then the hypotenuse would just be the hypotenuse of the triangle, which is RS. So here we would have a value of 4. I just want to erase this arrow. Okay, perfect. So now it's asking, what is the value of cosine S? So if you zoom in here on angle here, of angle S here, cosine is equivalent to adjacent over hypotenuse. So the adjacent value, we know of the adjacent value for angle S would just be square root 15. So in our answer, square root 15 should be on top. But what is the hypotenuse, right? Well, we don't even need to do any calculations because we know the hypotenuse we already calculated, which is 4. And so it's square root of 15 over 4. Our answer is B. During the month, Morgan ran R miles at 5 miles per hour and biked B miles at 10 miles per hour. She ran and biked a total of 200 miles that month, and she biked for twice as many hours as she ran, was the total number of miles that Morgan biked during the month. So there's a couple ways you can approach this, but I think the simplest way is honestly just through ratios and systems of equations. So first off, we have 200 miles that she runs in total. And we can set this equal to R plus T, because that's the total mileage that she ran, right? The number of miles she runs and the number of miles that she bikes. So now we want to set up a system. So in our case, we should have a variable. We'll call this x. So x in our case, let's say, is the total number of hours that she spends on the activity. So in our case, for running, we can just say 5x, right? So in our case, if x, let's say she spent 2 hours doing that activity. If she spent 2 hours running, it would be 2 times 5. And so that would check out. So if she ran for 2 hours at a rate of 5 miles per hour, guess what? She's going to run a total of 10 miles as her distance. Now, if we zoom in now for biking, that's a different story. Now, why? Well, first off, her rate is different, right? So instead of going at 5 miles per hour, she's going at 10 miles per hour. So it really doesn't matter whether she's running or biking, but it's only the speed that changes. And also if you have an external variable, which in our case we do, because she says that she biked for twice as many hours as she ran, right? So we can't just write 10x here because we know that she biked for twice as many hours as she ran. And so we can put a 2 on the outside here, multiplied by the rate of 10x. So 10x is just the amount of time, or rather x is the amount of time she just spends in activity. So watch what happens. So we have 5x plus 2 times 10x. So this becomes 20x. And this is 5x. So this becomes 25x equals 200, right? And so if we solve for x here, we get 8. So 8 doesn't have a really meaning in this problem, but if we plug this in to each of our rates, we can actually find the answer. Now why? Well, because we can plug this back into the 5x here. So we know that she runs 5 miles per hour. So if she's doing x activity for 8 hours, that's going to give us 8. So that's 40. That's 40 miles. And we know in total, she ran and biked a total of 200 miles. And so 200, boom, boom, minus 40 is 160 miles. And so that is our final answer. And there's another way you can check. Using this equation right here, 20x. So 20 times 8, right? That value of 8. And guess what? That also gets us 160 miles. And so our final answer is D. It says, the equation above is true for all values of x that is greater than 2, where r and t are also positive constants. What is the value of r times t? Okay, so this is a rational equation, and so we want to get rid of the denominator, right? So if we're trying to find a way to get rid of the denominator, we need to find a common denominator. So here it is pretty obvious, because on the right side we have x minus 2 times x plus 5. Whereas each of these standalone variables are missing one part of that, right? X minus 2, we can add a x plus 5 to that. And at x plus 5, we can add a x minus 2 to that. So I'll show you how it works. So for this one, 2 over x minus 2, if we multiply this by x plus 5 over x plus 5, we get the following. We get 2 times x plus 5, x plus 5 over x minus 2 times x plus 5. So whatever we do to the denominator, we have to do to the numerator, because x plus 5 over x plus 5 is 1. So in reality, we're not doing anything to it, but we're just giving it the same denominator so we can cancel it all out at the end. So the same thing is going to happen to the second term. So we have 3, and the common denominator here that we want to add is x minus 2. So 3 times x minus 2, be like that. And then we would have x minus 2 times x plus 5, and boom. And this is going to equal rx plus t. And because we already have this here, they list us, they give this to us. So this is all going to be the same, x minus 2 times x plus 5 as the common denominator. And so what we can do is just get rid of it. So all this at the bottom dies. And so now we're left with the following on top, 2 times x plus 5 plus 3 times x minus 2 equals rx plus t. So now we want to distribute this out. So 2 times x is 2x, and then 2 times 5 is 10, and then we add 3 times x, so 3x, and then 3 times -2 is -6 equals rxt. And this simplifies further, and it's actually kind of cool what happens. So we have 2x plus 5x, we're just combining like terms, and then 10 minus 6 is plus 4. So if we look at this, what you'll find is that on the left side, we have a x term and a constant, right? On the right side, we also have an x term, rx, and a constant t. So in our case, for r, we can just substitute in 5, right? So if r is 5, we get 5x, and if t is 4, we get 4. And that's kind of funny because left side, 5x plus 4, right side, 5x plus 4. Those two are equivalent, and so we know r is 5 and t is 4. And so they want us to find the value of r times t. 5 times 4 is positive 20, and so our answer is C. Function P models population thousands of a certain city 2 years after 2005. According to the model, the population is predicted to increase by n% every 18 months. What is the value of n? All right, so first off, we want to know how much it increases every 18 months, but in our equation, t is represented by years, and so we want to convert this 18 months to years. So 18 months is just 1.5 years, right? And so now what we can do is just plug 1.5 into our equation. And it's actually funny because 4/6 times 1.5 gives us 1, right? So in reality, when we raise the 1.04 to a power of something, we're raising it to a power of 1. And so this is all non-negligible when we're doing this calculation. 290 is our constant, so we start off with 290,000 as our population. And then 1.04 is actually that, I guess I'll call it like the factor that you apply, the growth factor. So this 1 right here represents obviously the initial amount. So let's say it was 1.0. That means the population would just stay the same at 290. But because it's greater than that, it's 1.04, what this represents is a 4% increase, right? So if it was, let's say, 1.1, that would be a 10% increase. And so we know right here, it's a 4% increase. So if we're looking at here, the question says, according to the model, the population is predicted to increase by n% every 18 months. The value of n is what? Well, we said n would be 4%. So the answer here is C. It says for the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? All right, so they give us, it says they give us 3 values of x. And so what we can do is actually make the function, right? Let's plot it out. So we have f of x. And so now we have to find out what the slope is. That's what the a represents because it's right in front of the x. All right, so to find that, we just want to look at the difference in between. So it's rise over run. So from negative 64 to 0, that's the increase of 64. And from 0 to 64, that's an increase of positive 64 as well. And we can see for that each positive increase of 64, so that's a change in y, our change in x is just plus 1, right? So we can determine that our slope is 64x. All right, so now we want to determine b. So b is the y-intercept. And so the y-intercept is the value you get when x is 0. Now it's not on here, but we can predict what it is. So we know that the difference between 1 and 0 is a x value of 1, right? So plus 1 here. And so we can just work backwards. So instead of adding 64, we can just subtract 64. And so here, minus 64, we'll get a value of negative 128. And so our x-intercept would be 128. So you could write this as plus negative 128, but it's the same thing. So it says, what is the value of a minus b? So our a value is 64, all right? And it's subtracting the b value. The b value is negative 128, all right? So if you subtract a negative number, we're essentially adding it. And so 64 plus 128 is just 192, so that's our final answer. The circle above has a center O. the length of arc ADC, the minor arc, is 5 pi, and x equals 100. What is the length of arc ABC? All right, so if we look at this, what we want to do is set up a ratio, right? So the first thing we know is that the angle x is going to be corresponding with that arc ADC. So our angle x, we can just write this on top, would be 100, right? And so it's corresponding to arc ADC, which has a length of 5 pi. And so now they want us to determine what is the length of arc ABC, right? This side right here. This side right here, right? So because we know that the circle is split up quite evenly, right? The degree value over here is going to correspond with that arc length of ABC. And so can we determine that angle? Well, we can't, because we know there's 360 degrees in a circle. And so if angle x is 100 degrees, we're left with 260 degrees, right? So this will go on top. And so now we can actually pretty easily figure out what our length of arc ABC is by just finding this corresponding value, right? So to do this, we have to do some simplification, or we can just find the factor actually, right? So from 100 to 260, that is a scale factor of 2.6x, or 2.6 times. And so we can assume that for the same thing on the denominator, to keep this ratio constant, we also have to multiply this by 2.6. And so here we can just do 5 times 2.6 pi. And that's the same thing as multiplying 5 pi by 2.6. So 5 times 2.6, that will give us 13, right? And then we can just add the pi at the bottom, or next to it. So we get 13 pi as our final answer. If square root of x to the 5th over cube root of x to the 4th equals x to the power of a over b for all values of x, what is the value of a over b? So first off, for this radical up here, for both of these radicals actually, we can simplify it and rewrite it. So square root of x to the 5th using exponent properties and radicals, we can determine that it is just 5 over 2 as the power, because in the denominator, that's just the index of the radical, and then whatever's under that square root or the power of the base goes in the numerator. And so this goes over this term, so this x, and this can be rewritten as just 4 over 3. And so now we want to find a common denominator here between 5/2 and 4/3. And so we can just multiply this by 3 and this by 2. So this would be x multiplied by 3, so you get 15/6. And then we multiply this by 2, so you get 8/6. And so now, because we have the same base, we can just subtract the powers. So 15/6 minus 8/6 is just 7/6. And so ultimately, they want to find the value of a over b. We can see a over b is just the power above x, and there is your answer. So the answer here is 7 over 6. The xy plane, the graph of y equals x squared minus 9 intersects the line P at 1a and 5b, where a and b are constants. What is the slope of line P? All right, so here's the thing, right? Since the graph of this equation y equals x squared minus 9 intersects with line P, and we are given the x coordinates of yp of line P, what we can do is plug in these x coordinates into the equation, find our y value, and since we know they intersect, then those coordinate points must be the same. And so whatever y value we get, we can just put it in for a and b. So I'll show you how it works here. So here, x squared minus 9, for x, we can just plug in 1, minus 9, and therefore we get negative 8. And then same thing over here for the second coordinate point, you get 25, 5 squared is 5, oops. Go. So we get 16. All right, so now we have the two coordinate points, right? We have 1, negative 8, and 5, 16. But they want to find the slope of line P. So that's just rise over run, or change in y over change in x, right? So our change in y is from -8 to +16. So that's going to be a difference of 24. And so 24 will go on top here for our change in y. And now our change in x is just between 1 and 5. So to go from 1 to 5, that's a change of 4, +4. So ultimately our slope is 6, and so our answer choice is number or letter 8. Figure above side BD is parallel to side AE. What is the length of side CE? All right, so first off, we have two triangles, right? We have triangle EAC and also triangle DBC. So the first thing to notice here is that there is similarity present between these two triangles. Now why? Well, because of angle, right? So for this first triangle, triangle EAC, it has that 90-degree angle in the corner. And we can see that for the other triangle, triangle DBC, it also has a 90-degree angle, which is formed right there. And now where is that other corresponding angle? Well, highlight it here now. It's going to be this angle C right here, right? So it's going to be present in both triangles, and therefore it makes the theorem of similarity true. And so knowing that these two triangles are similar, we know that the side lengths are going to be corresponding. And so in that case, we can scale up whatever numbers we already know based on a scale factor, based on the numbers that were given, in order to find the missing side length. So here, we're trying to find C, so this side right here. Oops. So, my God. Cannot draw today. All right, so first off, what is the scale factor? Well, we know the two corresponding sides here. We can look at right here, 6 and 18. So that's a scale factor of 3 between those two triangles, right? And now we just want to find the missing side length CD, because if we find that, we're going to scale that up in order to find CE. So CD, well, it's going to be equivalent to, we just use Pythagorean theorem. So we'll just say 6 squared plus 8 squared equals C squared. So we get 6 squared, 36 plus 64 is 100. And therefore, C squared. And then if we take the square root of both sides, we ultimately get C equals 10, right? So in our case, C would just be the side length of side CD. And because we know the scale factor is 3, we would have to apply the scale factor to our value of 10. And so ultimately, our final answer for the length of side CE would be 3 times 10, which would be 30. It has side lengths that are 166 times the side length of square B. The area of square A is K times the area of square B. What is the value of K? So it's a very straightforward question. You can draw a diagram if you want to visualize it. So I'll just draw 2 squares. So let's call this one square A and this one square B. All right, and we know the side lengths are 166 times the side lengths of B. So if the side lengths of B are X, call it X. Then A would be 166x. I'll just put those on both sides. And so to find the area of a square, we'll just do length times width. So if we have x times x, that will give us x squared. And then we want to set this in proportion to 166 times 166x. So that's going to give us is 27,556x squared. All right, so now we want to compare these two numbers, right? Because this is the area of square B, and then the one on the bottom is the area of square A. So how can we compare? Well, we can just plug in a random value for x. So let's say the side length of B was 1, right? So then we would get 1 squared. 1 squared is just 1. And then since 1 squared is 1, then we know for the bottom part, this is just equivalent to 27,556. We can clearly see the relationship here that the area of square A is 27,556 times. So ABC above is a right triangle, and sine of B is 5/13. What is the length of side BC? All right, so pretty simple problem here, except there is a little caveat that we have to take consideration of. So first off, sine B, I've marked the angle B. We know SOHCAHTOA, which is so sine represents opposite over hypotenuse. And so the opposite side would be a side length of 5. However, the interesting thing here is that it says the hypotenuse is a length of 13 when it's clearly marked 26 on our diagram for side AB. So what is happening here? Well, basically what we need to do is scale it up, right? Because if it's something that can be condensed down, it can be, and it's still mathematically correct. But so I'll show you the case here. So in reality, our actual length is 26, right? But our fraction here is 5 over 13. So what we can do is scale this up for the actual side length of AC. So since 13 times 2 is 26, then we can do the same thing to 5. 5 times 2 is 10, and so AC is a length of 10. So there we go. So we know that AC is 10, and now we want to find the side length of BC. So we don't know what BC is, but guess what? It's a right triangle, and so we can use Pythagorean theorem. So Pythagorean theorem is A squared plus B squared equals C squared, right? And we know it doesn't really matter. I guess I'll call AC or A value. So we have 10 squared plus B squared equals 26 squared. All right, so 10 squared is 100 plus B squared. 26 squared is going to be 676. And so if we just rearrange this equation, we get B squared, we get B squared equals 576. And if we take the square root of both sides, we can find that B is equivalent to 24, and therefore 24 is our answer, in which case that is the side length of side BC. So this problem says on May 10, 2015, there were 83 million internet subscribers in Nigeria. The major internet providers were MTN, Globalcom, and all those other ones. By September 30th, 2015, the number of internet subscribers in Nigeria had increased to a value of 97 million. If an internet subscriber in Nigeria on September 30th is selected at random, the probability that that person selected was a MTN subscriber is 0.43. So 43% of that 97 million were MTN subscribers. There were P million MTN subscribers in Nigeria on that September 30th date. So this is interesting. So this information of 83 million internet subscribers in Nigeria on May 10th is irrelevant to our equation. It asks to the nearest integer, what is the value of P? And let's remind ourselves P is the million of MTN subscribers that are on Nigeria on this date. Okay, so I'm going to be using not an accurate equation, but it just helps to, think about it. So I'm sure we've all heard of part over whole, right? It's pretty common in chemistry. So we kind of want to think about it like part over whole. So if we think about it, the whole value is just what we have in total, right? And what we have in total right now in terms of all the subscribers, internet subscribers in Nigeria is 97 million. So we just write 97 million there. And now we have to think about the whole, right? So now we have to think about the part. So the part is the number of MTN subscribers, right? So we know that the number of MTN subscribers is in terms of P, but P by itself is P million, right? So what we really have is P times 1 million. Boom, boom, boom. Running with the mouse is hard. All right, so now what you have to understand about part over whole is that finds percent composition, right? But we're not talking chemistry. We want to find the percent composition, quote unquote, of MTN subscribers in Nigeria, right? So of that 97%, what percentage of those subscribers were MTN subscribers? Well, that information is given right here, 0.43, which translates to 43%. So we're going to give a value of 0.43 here. So now it's pretty simple. We just have to solve for the value of P. So to do this, you just plug it into Desmos, right? But first, let's simplify this out, because if you type 1 million over 97 million, it's going to give you an error because it's just such a small number. So what we can do here is just simplify, right? So we have P, and then we just divide the 1 million by 1 million and divide the 97 million by 1 million. So we get P over 97 equals 0.43. And so you just chuck this into Desmos. I rewrote it differently, but essentially you just chuck it into Desmos and find the value of P, or you can name it X. Find an intersection here we can see is 41.71. We want to the nearest integer the value of P, and therefore our answer here is going to be P equals 42. Figured line M is parallel to line N, and line T intersects both lines. What is the value of X? All right, so first off, what we have here are vertical angles, right? So they give us 33 degrees here, so we know the angle across from that will also be 33 degrees. So if we call this angle right here that we just labeled angle 1, what we can see is that angle 1, and let's call this one angle 2, angle 1 and 2 are supplementary angles, right? Because two angles that make up a straight line will be equivalent to 180 degrees. And so if we know the total between those two angles is 180 degrees, we just found angle 1, right? Then we can find angle 2. And so angle 2 here will be 147 degrees. And this is helpful because we have two parallel lines cut by a transversal. And so we have our corresponding angles. Angle 2 that we have here and I guess angle X here, they are corresponding angles, and so they will have the same angle measure. And so since we know angle 2 is 147 degrees, X is also going to be 147 degrees, and so our answer choice is D. The function f is defined as f of x equals -8 times 2 to the power of x plus 22. What is the x-intercept of the line y equals f of x in the xy plane? All right, so first off, the number is probably jumping out at you, the plus 22, but don't fall into this trap. You know, there's always that answer choice that they want you to pick, but it's really just a trick answer. So instead of jumping to conclusions, seeing this plus 22, it's saying, this, everything else here is being multiplied and it's dependent on x. But something you'll notice here is that the y-intercept is the value you get when x is 0, right? So if we look at this more closely, 2 to the power of 0 is really just 1, right? And so 1 is going to be multiplied by -8. So 1 times -8, and that gives us -8. So in reality, we have -8 plus 22. And -8 plus 22 is going to give us 14, all right? So 14 here is going to be our y output when x is 0. And therefore, our answer choice is going to be A. Which expression is equivalent to 4 over 4x minus 5 minus 1 over x plus 1. So we have a bunch of answer choices here, and the first thing we want to do to simplify this for equivalent expressions is just get the same denominator, right? That way it's easier to work with, and we can actually do some arithmetic when it comes to it. So we see here that in the first term, we have 4x minus 5 at the denominator, and then for the second term, it is x plus 1. So we can do pretty easily is just find a common multiple between these two terms, and we can just do that by multiplying 4x minus 5 by x plus 1, and then vice versa, multiply x plus 1 by 4x minus 5. And by doing that, we also have to do the same thing to the numerator. So let's see how that works. So we have 4 over 4x minus 5, and we will be multiplying this by x plus 1 over x plus 1. You can see how that in reality that we're just changing both the top and bottom of the fraction, because x plus 1 over x plus 1 is really just 1. And so here we'll get 4x plus 4 over 4x minus 5 times x plus 1. And so now we'll just want to do the same thing to the other side. So here we're going to have this term right here, 1 over x plus 1. We're going to be multiplying this by 4x minus 5 over 4x minus 5. And so therefore we will get 4x minus 5 over, and then we get x plus 1. So that's just going to be the same thing, 4x minus 5, and then x plus 5. And so now we can also just look at this entire thing over each other, right? So we have 4x plus 4 minus 4x minus 5, but they have the same denominator. So in reality, this can just be rewritten as 4x plus 4 minus 4x minus 5 over all of this. So let's write it out again. Kind of tedious, but you gotta do what you gotta do. You'll see pretty interestingly is that some of the answer choices have this denominator. So we know we're on the right track here, right? So let's just evaluate the top part, right? So with 4x minus 4x, those two are going to cancel, right? So that's just going to be 0. But now in our case, we have 4 minus -5. So we're really just adding 5 to 4. That's going to be 9. So you have 9 on top, and then 4x minus 5. Really messy, but whatever. X plus 1. And so we have our equivalent expression right here. And we can see that actually matches up with answer choice D, and therefore that is our answer. Cube has a volume of whatever that is, cubic units. What is the surface area in square units of the cube? All right, so the first thing to recognize here is that a volume of a cube is just length times width times height, right? We all know this. So the thing to recognize here is that for a cube, it's made up of squares, right, as the faces. The special thing about squares is that each of the side lengths are equal, right? And because of that, we know that the length has to be equal to the width, has to be equal to the height. And therefore, in order to find the actual values of either the length, width, or height, what we can do is just take the cube root of the volume, which is going to be 474,552. And that will give us a value of 78, all right? So 78 is just the side length of each of the sides. And now we want to calculate the surface area. So for the surface area, we can just find the area of each side and then multiply by the number of sides. So we have 78 times 78. That will give us the area of one side. And we know there are 6 faces to a cube. And so we can just multiply this by 6, giving us a final value of 336,552.